Hmm. Hmm, hmm, hmm. Hi, Jeff.
Hi, how you doing?
Good, thanks.
Happy Friday.
Yeah, seems like it's been a long week.
Been a long week. You been traveling?
No, let's see, there was a conference on this week. Somebody sent me a link. It was a freebie.
Oh, okay.
I thought I'd drop in and see what they were talking about because then it was sort of one of these things where everybody sort of tackles the same problem, but in their own domain. So it's like sometimes you just hop across a different domain and you hear all the same problems, like phrased slightly differently. You know.
Yeah.
But sometimes the other domain has more money than your own domain, so it's like, okay, we'll move over there.
Yes.
It was Velox Con. So Velox is like SQL database stuff, acceleration. Like so, it's IBM and Oracle people and Facebook people and other things.
Oh, very cool.
Yeah, so there's this thing called Presto, which was like, a C++ acceleration layer on it, lots of caching and things. And then it looks like all the same kind of problems we see at OCP with like workload management.
Yes, definitely. And kind of all the same kinds of things we've been discussing. So,
Yeah, I was I was in the meeting, what was it, the 8 to 9 one this morning, a news meeting. Like somebody in from AMD discussing their problems of handling server farm stuff. And I said, some of these things are covered by some of the other groups. You should drop in on the 10 o'clock as well, and do the atomic Ethernet one.
oh, yeah. So I still have to ping them. So, but
Hmm. I was thinking we need a work group of a group of some kind that actually rationalizes what goes on at OCP. It's like there's a little
yeah,
bit of redundancy. You know?
yeah, we can talk to Bijan if he joins and how he connects some dots and do things like that.
Yeah.
Yeah.
Brian Harano turned up at the Velox thing.
Oh, okay.
Hesham. Hesham seems to turn up everywhere I go.
It's a small world, huh?
Yeah. Well, I was saying actually one of the things we should do since we have enough people for the Atomic Ethernet thing who are actually in Silicon Valley, we should just do a workshop day or something and hash out some of the stuff.
Definitely.
Where are you based?
Boston.
Ah, I'll have to find a good excuse to come to Boston then.
A fabulous day today. It's supposed to be in the high 70s tomorrow. Nice.
Ah, yeah.
Yeah.
I think
Boston
we're supposed to be. Okay.
Marathon Monday.
I can't run. I tried running for the train last week and it's like killed the tendons in my legs.
Yeah, so for me, my son and I, we live uh right near the finish line in Boston and at the front
Hmm.
of the marathon and turns into a zoo,
Yeah.
buddy descending on the course. So we used to live so we live on Beacon Hill now, but we used to live in back.
Hmm.
So essentially we were really close to the finish line. And for example, like for me to get a coffee, if I went to Starbucks to get a coffee in the morning, I had to go through like three security checkpoints to cross like two streets.
Yeah. I remember somebody talking about it was this, I think it was Freakonomics. It was a study on how well people did with ambulance services, and they were using the fact that the ambulances couldn't cross the marathon path to do some analysis. Days with marathons versus days without.
Oh yeah. Yeah, for us, trying to figure out, especially when we come to here, with an ambulance, you're going to definitely be going around in circles because they close in Boston,
Hmm.
probably the one of the main roads, Boylston Street, coming straight down. So
Hmm.
Yeah.
Yeah, you can look that one up on Freakonomics somewhere. I think there was another one on whether you're better off with or without the consultants being at the hospital when you got there.
Wow.
Generally, you're better off without, because like the interns won't do anything.
Happy Friday. We'll give it a few minutes here.
Hey Jack,
Hi.
hello everyone.
What's that?
I said hello everyone. It was just
Howdy.
Hi.
We'll give it a couple more minutes and then we'll kind of kick off. I only have one topic for me and we can discuss what everybody else wants to discuss.
Hi, Jack.
Hi. Thanks for responding, Bijan.
You're welcome. Sorry it took so long.
That's okay. I mean, we still have a month and so Bijan, I think where we kick off today, while we're giving the group a couple more minutes to kind of get connected is that so Minlan had the thing around power and AI and how do we start to advertise some of the pieces. Yasa and I have been talking about, are the ways that we can connect more into some of the OCP things as we start to look at like tangential efforts. And then for the life of me, I'm not going to remember that group, Yasa, that we sat in on the meeting earlier in the week. There was some group on neuromorphic something or other. And they were saying, hey, are there ways that we could start to figure out how we could link into OCP or basically have OCP link into some of these things. And so we're getting groups that are reaching out and say, what are the ways that we can kind of cross connect, do some things. And so Bijan, if there's a way that we could figure out how we do that or work on some pieces, as well as we have some research as we connect more into the research efforts, in terms of some of the software, some of the things that we want to consume or leverage or cooperate, collaborate. People are asking, hey, what are the things that we can do in partnership or jointly with OCP?
Yeah, I think that the neuromorphic architecture stuff, I'm sorry, the neuromorphic computing stuff doesn't really have a home internally in OCP right now. And I know that Cameron is usually on these calls.
He is.
I'm here.
Oh, yeah, he usually advocates for us to take a look at that. So yeah, I wasn't certain where it should be actually, but now that I've take kind of step back and thought about it a little bit, maybe it should be a work stream here to at least scope it and evaluate all of the salient things, like what's the timeline of it and what are the requirements for it and things like that. Not to derail any of the other work that's happening here in the polymorphic side, but if this, neuromorphic technology does come to market, then it will absolutely impact the polymorphic stuff, right?
I tend to look at it a little differently. So you're going to end up with a bunch of stuff that looks like neurons passing messages, but that particular paradigm works for a lot of things. So it's more about like enabling the paradigm of lots of little processes sending messages to each other. And it sort of covers the smart network stuff as well. So it's just trying to pull out the abstractions that cover it all.
Yeah, I wasn't certain if it, like I said, it didn't really have a home, and I was wondering if it worked over there at the Atomic Ethernet stuff, but it doesn't. It really fits here better in my mind.
Yeah, so
Yeah, it's kind of too low level at the Atomic Ethernet.
Yeah. Mhm.
Yeah, so Bijan, one of the things that we discussed, and I talked to Yasa during the week, is as we start to look at kind of the AI software side and the algorithms part that Yasa is working on, neuromorphic could be a possible target, that we could map to on kind of that hardware software co-design. I'm hesitant, but we're a working group, so we all work together to say, hey, we have neuromorphic, we got a hammer, what nail do we go off and hit? But I think if we kind of turn it the other way around, saying, hey, we're investigating these particular algorithms, these particular pieces, and here's kind of the hardware, software, the compiler side, some of these elements, and we say, oh, by the way, same way we're doing on the fabric side for the AI space. Here's the characteristics, the elements, the pieces, and we think for these particular, this swim lane, we think neuromorphic's a really good fit. And then we just have to figure out, is there a way for us to actually materialize into some level of POC or white paper or characterization in terms of that. So we've had some level of conversation, and I pinged Hesham and Kevin said, if you want to put pen to paper, that'd be great, but we can find a way that we can actually do that.
Can I quickly chime in here, Jack?
Sure.
Just because on Bijan's point, also to address this with the neuromorphic perhaps. So it is actually a topic which is very close to my academic home. So I've worked with neuromorphic myself, and lots of my collaborators do. So we are going to cover it on the algorithm side anyways, to a degree. We were already planning to it, also partially because if we think about polymorphic, it's actually one of the architectures which is closer to market anyways, because obviously like Intel and IBM and stuff at least have running research chips available. And we have actually access to the Intel neuromorphic cloud in our research group anyways. So, this is a long way of saying we are consider it addressed in the software and the algorithm workstream for now. And I'm happy to feedback to anybody who's interested into the details of like what can it be used for.
That was my feeling. I just didn't want to speak for anybody.
Yeah, so all good, Bijan. Thank you for bringing it up. And yeah, I do fully agree that it should find a home somewhere.
So I already mentioned this. I believe in neuromorphic computing myself, and I already brought 2 speakers about it. And Monday we are having a meeting with IBM, one of the top researchers in IBM Madden Research Lab here in San Jose. He's gonna talk about neuromorphic computing and IBM. And that meeting, I got 60 people accepted to attend. So it is really very popular topic. The other 2 meetings were also very well attended. So this is a topic I think we should investigate and spend some time to explore it. So I really agree with Bijan. We should have maybe a whole work stream to look into it. And maybe the output will be some white paper or proof of concept. But I think this topic deserves some attention and focus from OCP somehow. And since neuromorphic target algorithms for hardware and software to develop better or better performing AI systems. So that work stream can be a good fit, or this group can be a good fit for that work stream. That's my opinion.
I'm kind of looking at it as the fix for the power problems you see with the matrix math LLM type AIs. So basically there's a neural network in those LLMs, but it's matrix math and it's not very
Yeah, it
efficient.
is not just, of course, energy, reduction of
Yeah.
energy consumption is a big benefit of neuromorphic computing, but it has other benefits as
Yeah,
well.
yeah.
Yeah, and the IBM guy on Monday will talk about this. There are many approaches to neuromorphic computing, right? So really, it's a big topic, and lots of research has happened in this area. So we should look into it and see how
Yeah.
the co-design, hardware, software co-design of AI systems, how it can benefit from neuromorphic computing.
So
Yeah.
I
Sorry.
I appreciate that. And I guess the other thing is that, and Hesham, thank you for kind of setting up the education part. But I think at some point when we turn the corner on the education part, we're going to need, I think if I look at, Weifeng posted some things in chat around what's the goal and, what are the advantages, pros, cons, kinds of things. Where does it fit? Where doesn't it fit? Yasa had just talked about some things that, he has a lot of information. He's been doing some things on the algorithm side. So how do we move from the education part to actually doing something a little bit more concrete? And so if we're okay with this group, kind of developing that work stream, which really says not only are we looking at kind of the AI space, but also a specific targeted area around that, I'm fully supportive, but we're going to need people raising hands that are going to put pen to paper to help us kind of move some things and organize some of the work. So Yasa's leading kind of the algorithm side, but we'll need kind of the hardware side piece to make sure we're connected. I would like us to kind of, this group to collaborate together, otherwise quickly we'll end up in October where we're saying, hey, this should be something this group should look at, and we'll be having the same conversation. So I appreciate.
Yeah. So how we can start, Jack?
I think Jack's laid it out. I think we could, kind of, it needs to be a survey done, right? The survey needs to answer key questions like what is the usefulness of this idea? How does it pertain to solving problems in the area, the domain that we're in? And what are the kind of timelines or requirements that it might have? Because you don't want to start down a path and find out the requirements are unattainable. So I think that's the first step, Hashem, is to kind of, create a summary. And it could be very terse, very rough. Oh, I think CMX said something like that too. Yeah, so I think it'd be very terse, but we do need to, if we want to make sure that we're not missing something, and or maybe this is, maybe this is a roadmap of the polymorphic architecture, right? So maybe this work, it says, we do all this work and we say, okay, this is phase 3 of this polymorphic architecture and it's neuromorphic, and then we know what we have to do. We know that we have to start working on it slowly at the same time that
It's kind of just another hardware platform, though. You can say, okay, we're going to bring in people's neuromorphic processors as well as the other things we've considered. What's the general software flow for this?
But I think but to Jack's point, we need to keep it, tied to what we're aiming to do. So I think that, we need to just keep the focus on AI systems, high performance compute and AI systems.
Yeah, and I think, Kevin, to your point, I appreciate, it's just another hardware platform, but if we don't characterize it or provide some sort of guidance or at least an opinion, we're going to end up in some sort of weird space. And so Brian had texted me. So if we look, there's the Project Phaser work, which wants to connect with us, and they're looking at some neuromorphic. Yasa's doing some work outside of this group and looking to connect to this group. VJ is doing some work around Neurobench. So there's a number of related efforts. And then if we look and say, okay, based on where we see some things going, and so, Kevin, you mentioned some things around power or things like that. So in addition to VJ, there's so Min Lan reached out to, I introduced her to Bijan. She's doing some things around power and AI. And, you know, so there's a number of these things where we're have a collective of related topics that maybe what we do is say, based on these things, the intersection for this particular space could be neuromorphic. And, oh, by the way, here's the pros, the cons, where some things fit, you know, how would we demonstrate, what kinds of things we go through to, you know, it's drawing a line in the sand, of which there's always going to be some religious argument that we're going to end up going, you know, somebody's going to say, well, mine's better than this. And, but it allows for people that I think, especially as we get towards OCP, where people look and say, I don't even know what neuromorphic is. Now we can describe it, you know, Hesham's going through the education phase. We can actually start to articulate some of those things, the applications, what problems get solved, you know, how I think Bijan brought up a great point. How close is the hardware? You know, what kinds of things? When do we see a horizon? What does the roadmap look like? And now people can start to see some of these things coming along, but also all the different related groups that are trying to connect to OCP, who are working on this either directly or tangentially, who want to partner, and then we can find the other groups in OCP that it may connect to. So Hashem, to your point, I think Bijan brought up a great point. Let's do it here to kick it off, but then find the related things that are going on, both within OCP and other groups, to make the connections. Because I think as we start to look at this hardware, software, co-design, there's a number of groups reaching out and saying, hey, where do I connect OCP? Could I partner with them? There are ways that I could share my effort with OCP, and OCP share some things with me, so we could be better together. So there's groups that are looking to leverage us.
And also Kevin and Heshem, if you guys can you know, recruit anybody on the outside to help with that effort, that would be wonderful. I think, you know, just because we're few, and I could feel that Weifeng's concerned about us taking on too many things at once, and he's right to be concerned about it. So yeah, if anyone can recruit some help, that would be wonderful.
So,
To
Bijan,
help along with, we cannot do everything at the same time. As you guys know, things can run independently if we have clear interfaces defined. So maybe you can articulate the entire thing that is in a black box, and then you need so many of these black boxes to be interconnected this particular way. And if you look at it from 100-foot level or 1,000-foot level, it might look like another thing that we're doing with a different black box. And therefore, you can get people to go work on the black box, exactly what that computation element is or the software that runs, but keep everything else the same, that you can benefit from the momentum that's being created through AI ML a different way.
Yeah, I would say you're right there. And what I see as missing in programming is the communication piece is not integrated into the serial processing piece. And
Very
the
good.
neuromorphic thing is sort of going to help us define that.
Very good. So again, you're identifying the problem. In other words, you say the interconnect is not my problem. The fact that I need memory is not my problem. The fact that I need storage or networking to collect new data is not my problem. My problem is inside that little black box that is doing the computation element. Then it can guide all of us to focus.
Yeah, and I think you bring up a great point about the black box in terms of that. The one thing that has come up recently, especially as we start to look at the modeling, so moving from white paper to modeling, you know, every single request we've seen so far said, hey, can we build a foundational modeling, a system model framework? And then from there, people could plug in their piece. So CMIC, you bring up a great point. You know, are there ways that we could do compute modules? Are there ways that we could hook in things? But we're really trying to, and I can go through it, but we're looking at kind of that compute communication. But people are saying, well, could I also connect in? What abstraction do I have where I could start to hook in black box elements? And I had this conversation with Min Lan at Harvard as she's doing some of her research. Could we start to work on this abstraction, which allows us to work on kind of the compute communication elements, whatever it turns out to be, from chip all the way up to large scale systems. And then people could hook in as a black box some element of something they may want to have.
Right.
They could plug in. And so I think that's the approach. We have two approaches that we'll discuss, but she had talked about that. I talked about that with Yasa, with Tushar. with the HPE team, are there ways that we could start to build kind of a much more of a pluggable, so people would say, I don't want to disclose this, I could do this, I could hook it in, and then they could test things out with the model to look at pros and cons.
Right, because you can imagine the opposite, in that we don't identify interfaces, we don't identify this framework or hardware structure, and we get really confused and go into the spaghetti of things. Everybody will question other people's assertions or assumptions.
Yeah,
So-
and I think that, to your point, you know, if we're public about everything we do and we take a stance and not be defensive, then now people can see the premise that we built, the foundation, and why we did things a certain way, and say, well, have you thought about A versus B, versus I picked an implementation and I said, this is now the hill I'm going to die on. Then we turn it into an argument that's going to be hard to defend. And I think, to your point, give people a chance to try, do work on some things. It's just guidelines. And we think, here's the line. People may want to shift the line left or right, versus if we were really hard and fast about a specific way to implement, and we said, this is the only way, that would be difficult.
I just want to reiterate the point that was made earlier. Like, you know, in the state of Texas, they say good fences make good neighbors. Well, here, good interfaces make good neighbors, right? So I just want to reiterate that point, that defining the interface is halfway towards abstraction. And if we're able to do such a thing, then, you know, people can plug and play, you know, theoretically, many different types of, you know, black boxes.
Yeah, and so Bijan, we're gonna have to be super crisp, because I had a conversation this week, more on the hardware side, and interfaces, you know, PCIe, Ethernet, you know, going through, versus, okay, then if I have a conversation with somebody else, okay, interface, now it's this hardware software kind of thing, what the APIs look like. And so I think as we go through all the layers, we're gonna have to be, we're gonna have to be very crisp on our language and terminology.
I prefer languages and compilers. I would say languages and compilers rather than APIs.
On those points, I think it can start with this, making some assumptions about standard things that are already there. If the standard things that are already there, satisfying what you need, we're done. If not, you identified a gap that we need to work on.
Okay.
Can we
So,
get a volunteer to
So,
really drive this as a work stream, so that I saw there was a lot of background discussion in the past weeks. And then we just want to really convert this into an action.
On the neuromorphic side, Wei-Feng?
Yes.
Yeah, okay.
yeah, so I agree with you, but Bijan, maybe I would like you to summarize what you just mentioned. You said we need to start with a survey or define
Yeah.
requirement.
I think okay, so I think, you know, in order, what I would do is we need to identify some leadership, right? Who's gonna help drive this forward. And then after we've done that, then we need to come up with a kind of a survey of the state of the art and report back, right? What is the state of the art of this? How close is it? How far is it? You know, what problems and challenges there are. And then once you've done that, the survey, and then you take another look and say, okay, does this make sense to take this on right now? If it does still make sense, then the next step on that's going to be to define, you know, what are the requirements, and how could this, you know, how could this benefit our efforts here, that type of thing. So then you're trending towards making a white paper at that point, but there's a few intermediate steps before you get to that.
Yeah, and so what you're saying is, because the two presentations, in addition to the one I'm gonna have on Monday, that should provide the survey you are looking for. It gives the introductory information you're looking for.
No,
One voice is part of a survey. I agree, but we
Yeah.
definitely would want to look at, you know, a broad spectrum of, you know, pros and cons on this, and make sure that, you know, we do the right thing. I think that it's a new area, and, you know, so we don't, you know, I just had this wonderful conversation about reversible computing, for example, right?
Yeah.
And we are all for reversible computing, and we're all excited about it, but there's some real big challenges that stand in our way before we can get engaged on this. So, you know, that's all I'm saying. It's just measure twice and cut once, if you want another saying.
Yeah,
I
but
think there's a slight issue with the reversible computing thing, something where we kind of have a problem that we're defining hardware as Verilog and RTL, and that doesn't mesh well with some of the newer techniques for doing logic or computing with analog and stuff.
Yeah,
And
I'm
one of the
sorry
things is
for
try to get a level above that.
Okay,
yeah, I'm sorry
I-
for bringing that up. That's another
I
thing.
mean, it's a
Yeah.
good point though. I think that as an AI hardware software co-design group, you know, it's like how do you do a different kind of design from the workload end?
Yeah, so I think I just took it as an example, Bijan, but Hashem, to your point, you know, you're hosting the talk on Monday. It's an example of a possible survey, but we can't push, you know, hey, they're going to present a survey. We can't push that on them. So we own the survey on our side. So if we want to use that as a template, I'm all for it in terms of this, but if that's an example that we would like to use, but we own it in terms of this versus, hey, a survey was presented, so, you know, no, if you want to summarize and do things like that, fabulous.
Yeah, so what I'm saying is the information provided in this, the previous two and the one coming on Monday, that information can feed into this survey that you just mentioned. The survey of what is happening in anamorphic computing and the state of the art research in this area, pros and cons. The information in this calls or presentations can feed into this survey paper, for example. And there are
think the
so many
survey-
survey papers. There
I
are
think
many
this-
pneumorphic survey papers.
Yeah, I
Well-
think the survey here is not trying to reproduce everything because certainly there was a lot of work already there. So I think the survey is more help us to identify exactly what we need to do here.
Right. And let's not underestimate the complexity because there's so many different ways to slice and dice neuromorphic. So
Right.
my text to Jack was well, it was, VJ, I don't know if you know, but when he was doing the neurobench, had a big headache to trying to reconcile the people that are doing more analog things versus people doing digital simulations of spiral neural nets, right? Spike networks. So, like the low-E stuff from Intel. Well, that used to be at Intel. So we'll see if we can. Don't want to volunteer VJ, but I think that would also be constructive of this discussion that as to someone having to integrate across these various forms of quote unquote neuromorphic. So, either Jack and I will see if VJ will have time to do that. But I don't want to commit to him doing that without having either Jack or I talk to him first. So there's complexity here. So I think that's also part of the survey is just to understand not only the survey of all the technologies, but then how do you make sure that all these technologies are going to play well so that we go back to, measuring the same thing when we're comparing them, right? And so.
Yeah, and I think that, where we were discussing before, there's a number of different groups, peripheral groups, things like this that are reaching out to, to OCP as well as, we're reaching out. And so I think it's really, I think as Weifeng and Bijan were discussing, is there a work stream that we could form that could look at all of this and say, okay, this is what this group could do. Here's all the different efforts. Here's all the different things. To Brian's point, what have they covered? What's been difficult? What's easy? What parts could we do in this group? What parts fit to what our mission is? How do we leverage things like that? Could we evangelize to other groups so that we could learn from what they're doing as well? I think would be ideal. And I guess the only thing I'm suggesting is quickly we could end up in the summer and be having this exact same conversation. So Hashem, to your point, there's a lot of survey work, there's a lot of other groups. How do we start to sample that and start to at least build a framework structure of kind of the next steps?
Then why don't we have a work stream to do that?
I would merge it with the cognitive networking under Atomic Ethernet.
No, I wouldn't merge it with that. Absolutely. This group doesn't even know what it's doing, honestly.
Well, that's part of the problem.
Yeah. So I wouldn't
mean,
merge it there. Absolutely not.
if
If
you're going
there's
to
a
something
hole-
like a neural
Yeah,
network
if
is
there-
something with an awful
yeah.
lot of communication. I mean, the thing
Yeah,
we've got like photonics and millimeter wave radio and stuff like that, and massive amounts of communication to go with the compute. So you're really trying to mash those two things together.
Okay.
I think it's
all right,
outside. It's outside the atomic Ethernet scope right now.
Yeah. So In the interest of moving this forward, I'm going to ping a few of you. We're gonna put together kind of a bulleted list, and a purpose statement, kind of thing, and we'll review at our next meeting. So be prepared that I'm gonna start pinging a few of you to gather some ideas, work on this, what we think is important, what should be included above the line, below the line, and Wei-Feng, to your point, a goal, as we start to go through. So I'll do that for the meeting in 2 weeks.
A good idea, Jack. Let us do that. I agree with you.
Okay, and you know, I know who on this call I'm going to ping. Yas and I talk every week anyway, so so I'm definitely going to pick him. But but we'll yes, and from our point of view, we aren't looking to, because it has to fit into, I think, kind of the direction we're going to go. Bijan, I think, because 4/9 became a book date, we're on for 5/14, and right now we have two kinds of things. And so maybe if we're well formulated by 5/14, we'll add neuromorphic onto the presentation to the OCP AI strategy thing, the update from our group.
Sounds good.
Okay. So I appreciate the lively conversation. I don't want to close the door, but is there anything else that we, on this particular topic or any other topics? And then I'll just do a quick update on the model, and then that's what the part that we'll do for today. Okay. Can you see my slide?
Yes.
Okay. I'm just going to do the update then, okay. So, so it, let me, so as we kind of look at, I have a whole bunch of stuff building up, but I'm not going to go through it all. As we talked about last time, with Prakash around compute communication, around the model, we've been looking at different workloads. So I've been communicating offline with Mike and Semantica from the HPC side. We've been driving kind of the AI side. I've been talking to Yasa around algorithms, and then we still have kind of an open thing around edge. What are some things around compute? Obviously, we've been talking about neuromorphic, but we have some things emerging around networks and how do the compute communication elements work. So this is essentially kind of the framework. The green bubbles are kind of things that we're discussing in flight. The blue things are already there as part of AstroSim. And there's some elements that, that we're going to go through. So Minland does a lot of research at Harvard around network communication, network characterizing different interfaces, CPU, GPU, GPU memory, GPU, NIC, things like that. She's looking for some help around power and AI. She's looking for some help around AI workloads, some guidance and things like that. But she has students and is looking to really kind of build out some of the research. But she has a lot of characterization around networks, checkpoints, data movements, things like that. So we're going to figure out a way that we can actually work together and start to leverage some of her data points that really help us around the swim lanes. Yasa and I talked about, how do we start to look from an algorithm side, feeding into the workloads. There's some things around today. AstroSim allows us to do a static topology as we start to look at the configuration around compute communication. Can we make it far more dynamic? So as we start to look at the workload and the characteristics, are there things that we could actually go ahead and understand, how's the topology working? Could things change? Could we start to take some of the work that Tushar's been doing around topology aware collectives and make that much more in terms of a dynamic network, and then map into Minland? She's doing a real network simulator. Can we do real networks connected into AstroSim? And so it gives us a way to kind of extend the model. And so Tushar and I had a conversation of how do we start to abstract the model around pluggable things, fits back to our black box, and start to look at different ways to build up traces as we look at the different workload types and how far can we push. So if we can crisp up our proposal, he does have some students that we could leverage. I sent mail to Namsung about remote memory, near memory compute. And we're going to have a conversation, not next week, probably the last week in April, about what does that look like from a compute side, you know, so it's not necessarily, you know, for everything we come up with, it's yet another module that we're going to create for AstroSim, and now we end up with dozens of modules. Can we create kind of a common framework and then just look at things as different workloads? So we have near memory compute, which just has different kinds of characteristics. How does it hook onto the network? What kinds of things does it have? How do we start to look at some of those elements? And then, you know, HPC obviously has different fabrics for some of the things we've been looking at. And they've been looking at some things around kind of the dynamic scale up, scale out, and some of those pieces. I can't see my chat, so if somebody wants to speak up, just yell. Jay's still working on the scale up. Prakash has been, as he said in the last meeting, scale up to scale out. Tushar asked about data storage. Could we build a storage module for AstroSim? And I came back with a counter proposal. I said storage is really data services on distributed compute. And so we're going to turn it into a different application kind of profile on compute communication. And so from this, Tushar has some questions about how do we do open source? What kinds of things do we do? There's been a number of conversations around ML Commons, traces, you know, workloads, things like that. And we're still pursuing those elements. And so we've been kind of from whether it's large scale AI training, looking at the algorithms and kind of the frontier that Yasa presented, some things around edge AI, and there's been some asks like in terms of modeling, because now it's just compute elements, whether it's UCIe and chiplets, or it's systems and I bend sheet metal around boards, or if I bend racks around systems, or if I scale out pods, you know, are there ways that we can start to abstract some of those pieces, and it's really built into the characteristics. And so this is the approach that we're taking. So we've been obviously Yasa's at Oxford, Minland's at Harvard, Tushar's at Georgia Tech, Namsung's at, you know, at Illinois, and then there's the team that's on here. This is not an exclusive list by any means. Anybody who wants to jump in, offer an opinion. I told in my reply to Semantica and Mike from the HPE side, I'll get the Google Doc up on the terminology and the data services side. Jay has been building his stuff as well in his document, and I have to just reach out to Prakash so we'll move everything into, I'm going to create a work in progress directory in our Google Doc, in our Google Drive. And that way you'll see the document getting formed in terms of the pieces we want to go through. It'll be open to everybody as a contributor. I just appreciate more of a collaborative kind of thing. And if we have any talking points, things like this we want to go through, we're going to use our bi-weekly meeting, but much the same way we talked about with the work stream for neuromorphic and doing it much more asynchronously. We had the same conversation around HPC. We had the same conversation around the algorithms and the AI fabrics. Everything is going to be kind of asynchronous work through the work in progress directory. And then we're going to use our bi-weekly to kind of provide status and then hash out any arguments, difference of opinion, whatever, in terms of what we want to go through. But we're really trying to kind of close out in the coming weeks, so we can really start to shift towards modeling. And so I've spoken with the Dell team about data services on distributed compute as well. What are some things? And I talked to Tushar and Minlan about what are the ways that we can look at like synchronous, asynchronous boundaries. You know, how do we start to look at the different ways that we can actually handle data services, model domains, do things like that. And so I think everybody's starting to align. And now we're just going to kind of get down to actually doing. So we're hopefully going to finalize this in the coming weeks for us to march to POC. I will say, and sometimes when I talk about it, I think we're making tremendous progress. And sometimes I feel like October is going to come so fast, it'll be a blur. So. Did I go offline?
Sounds good.
Oh, it's just rattling around in my brain. It was a good update.
Okay, as I said, we'll put everything in the work in progress, and if you want, anytime we do an update, we can send it out to the list so people can go probe, you know, read, go through. I just ask as a contributor to sit on review mode and make it a suggestion so we can have a dialogue versus just randomly deleting text. it'll be difficult. So, but hopefully this seems to seem like we're kind of making progress. So Weifeng, so yes, work streams, fabric, algorithm, simulation. Yes, those are the work streams that I think, and neuromorphic is the one where I'll do the proposal for. I have missed a number of discussions. What level of fidelity is target? That one I'll have to take offline. I guess I'd like to understand what do we mean by fidelity in terms of this. And Randy, you know, as we start writing, if there's questions you want to ask that we become super specific about, you know, in terms of that'd be great. What's involved in data services? So today, from a storage point of view, we look at things, we have things, I've talked to some about inference versus training, data movement, transformation. We can do compression, dedupe, encryption, but we also can shift data. We've had some conversations if we look at things around objects, transforming objects, you know, as we move much more from a compute to a long-term storage. What are the things we manage state? How do we manage state? I still have to close the loop with Shaw Meyer, who's on the phone around. He does a lot of work around SDXI for storage in terms of data movement as we get back to our interface discussion to make sure that we're aligned, because that's actually a published interface. And what are the things we do to look like we're not doing yet another interface. So Victor, you'll see it as it comes up on the work in progress. And if we miss something, or if you think we misrepresent something, just chime in. But Randy, if you want to either jump in, or as things get posted by Monday, if you want to just post a question, that'd be great on fidelity.
Yeah, I was just thinking, and I know I've shared some emails with the people, and my concern is, and I saw from the notes there was some discussions about ANNs, and from my perspective, they don't bear any relationship to, you know, the way real neurons in our brain function. And so that's kind of where I'm looking at the level of fidelity that we want to consider. Because there may be a number of differences, whether it's spiky or others. It currently, looking from an energy perspective, if we want to capture the correctness, I think spikies are certainly the closest, but still that doesn't count correctly for the energy model, the way neurons operate. And so that's why I'm wondering what level of fidelity. And just as an aside, I saw the networking. And just wanted to highlight, based on some recent work I did, is that essentially in the last 10 years, power consumption by networking, meaning from the port, hasn't really changed in them at all from the last 10 years. So I was curious what they're looking at in terms of the networking, because we know in accelerators that the utilization of accelerators, you know, to get above 30% or even 40% is a stretch, simply because the IO is the bottleneck. And so that's why I'm curious where the networking aspect is going to go.
Yeah, so Minland, she and I just spoke, you know, for the life of me, I'm not going to remember, but we just spoke. And when we were talking on Wednesday, she's done a lot of work in the past on like pure networking, you know, pure networking, P4, things like that, doing a lot of things around Ethernet. But she has now shifted in terms of data movement, looking at different interfaces. She's doing a lot of work on PCIe, on Ethernet, moving, as I said, checkpointing. So to your point, Randy, a lot of these things, you know, because we're not computing all the time. So she has some thoughts around compute communication, which does impact our overall efficiency of some of the things that we do, because, you know, I'm not computing if I'm transmitting, or some of these types of elements. So she has some data, and we're going to start with that as a stake in, you know, stake in the ground, you know, for us to get started. And then from there, we can start to have our dialogue. She's very open to it.
Yeah, and it's interesting to say that, because we've done some work over the last 3 years looking at InfiniBand versus Rocky, the you know, RDMA over converged Ethernet, in terms of performance and efficiency. And one of the reasons that ROCE seems to be very viable in many applications. So I'd like to follow up separately on that.
Yeah, so sure, just please reach out, in terms of that. Because the other thing too, much the same way we talked about like neuromorphic and you talked about ANNs and SNNs, and we get into, we're not here to, I don't think as this group to look to endorse and say, hey, this is the only right way to do it. We talked like Jay was going through like NVLink. Now we have UA Link, or we have some other things around scale up. We aren't looking to say, oh, when you think scale up, it's only NVLink. And if we look at like some of the networks and efficiencies, we may characterize it in such a way where people look and go, oh, that's InfiniBand, or that's Ultra Ethernet, or that's this, but if you look at it, it's not just InfiniBand, but it's also the characteristics is, how did I configure my network? I had a long conversation, from the HPC side, they use different networks and different topologies. And so we have clone networks in this side, we may do, Dragonfly or some other kinds of things. We build mesh networks. We build mesh networks on chips. We build mesh networks in terms of scale up. And so if you look at some of these pieces, are there ways that we can start to characterize these elements or provide guidelines where kind of the pros and cons, or at least the characteristics, and then we can do that with the modeling tool? Are there things that we could do from a system modeling aspect that says, okay, yeah, from this, with these characteristics, we see this kind of outcome, or we can produce this kind of result? We're trying to invoke hardware software co-design be built.
And that's interesting because currently, from my perspective, latency is the huge, perhaps undiscussed topic, and that may be something we also consider as because that has to do with efficiency and performance. So maybe latency is a topic all its own.
Yeah,
that's one we're discussing in the Atomic Ethernet. Since people want low latency computing for certain things, and we're looking at that in the Atomic Ethernet group. So say, one of the things here is you can look at a network card as just another accelerator. It's just accelerating different things. So whether you're plugging in some particular AI accelerator or a particular network card, there's some commonality in that interface possibly.
So Jack, just as a data point to kind of what you're saying, so we kind of have the similar discussion within the composable memory systems group because we had our CMS Tech Day, and one of the things that we've been doing is sort of expanding on what the logical architecture of this kind of is the domain of this group. And so, kind of to the point of, wires versus implementations of those wires, it'd be good to remind what the logical architecture is, and then the implementation could be what the implementation is, right? And then how that maps into that particular logical architecture. So I'll just forward you that presentation from CMS Tech Day just to kind of show you what's being reported there, and then maybe that'll help drive some of the discussion that you just had about connecting compute and wires and memory and storage or whatever it is, and then let's worry about the Rocky and InfiniBand and all those kinds of issues, UA Link, whatever it is, and those are kind of implementations that we might choose to instantiate, give an instantiation of that particular logical architecture.
Yeah, and I think that's a great point, Brian, because if you look at it from a logical point of view, and I think we do the system model correctly, where you look and say, here's kind of the characteristics that we went through and we modeled. Then if somebody said, well, okay, here's the characteristics, I'm going to come along and I'm going to build essentially what would be my flavor of UA Link, they could see how it would work, but that's somebody else kind of invoking their specific piece. But I think to your point, if we keep it at a logical level and we think we agree on the kind of the direction and how it's represented. And I think, Randy, I want to be real crisp as we look at latency where for what application doing what thing, because I could take it and misconfigure it or do some other pieces. And now latency is like, I broke it just because of the way I did it.
Exactly. And that's why I think keeping that focus, because then it's implementation agnostic. It's just how do we get there type of thing.
Okay.
And part of trying to go with AstroSim is to sort of tease out some of these things in simulation, and then say, try and get a topology for the compute and the communicate in something like AstroSim, and then say that's what we need to compile.
So Kev, I'd like to follow up offline because I'm not real familiar with AstroSim, and
I'm not either. It's just one of those things. We need some simulator.
Yeah, I agree.
And AstroSim popped up. I haven't dug into it.
Yeah, so Randy, we're kind of diving into it now, and then we're going to meet with Tushar and go through what we can and can't do, things like that, going through some pieces. I'll forward out to the group kind of the tutorial so you get to see it. But we're gonna bend the model a little in terms of this. So we have some
Yeah.
work to do, but AMD, Tushar's students work at AMD, NVIDIA, Meta, some others, and so there is some energy in the system, and the question is it just something where Tushar's doing from Georgia Tech, or if it turns out to be a good tool, can it fit into kind of an open source stream that we could now start to collect traces, do different workloads, build pluggable modules, and have it represent things with your point, with some fidelity that people can look and say, yeah, I can trust this, versus, it's a heavy lift. It's written in some sort of cryptic scripting language, and it requires tremendous handholding. Nobody's going to use it. And so there are some things we have to kind of go through. Okay.
I have
I'm gonna say we have 10 minutes left. I'm gonna go on mute. We're open to any conversation. I told you, like, when we get together, I talk quite a bit, so now I'm not gonna talk.
yeah. So I have one question for Bijan. You said our time horizon seems to be present 24 months in the initial work. Do you mean we need 2 years to do the initial investigation?
No. What I meant was, yeah, I didn't put all the words in there, but what I meant was that based on our first works that have happened, on polymorphic architectures, it's taken us more than a year to get to this point, right? And so I think anything we consider for neuromorphics, to be fair, we should give it an equivalent amount of time. So it 12 months, not to finish our work, but 12 months to 24 months to see a commercialized or a potential system that we could define.
So for example, Bijan, if we talk about this initial survey that you allocate to it 2 months, for example, or 6 months, or
I think we need to work quickly.
yeah,
Actually, I think the initial survey should be very quick. I don't think it should take many
exactly,
months.
exactly. I agree.
People have already pointed out there's a lot of work out there,
I
so
know.
I think
I
it's
know.
just a matter of us sifting through and organizing the knowledge, right? And then to kind of report back and say, hey, this is the state of the art. This is what we found. This is what's important. This is
Yeah.
the good parts. This is the unsolved parts, right? And then as a group, we can kind of discuss, like, what's next? Like, what do we do next?
Okay. That is fair. You're right. And after that, we decide what to do, how to move forward.
Yeah, exactly.
Got it. Got it. Got it.
Because I mean,
And
if you play it forward, I mean, if this is a commercializable thing, maybe this becomes a plug-in component, of this architecture, and maybe there's other things like that out there that we should systematically review and see, do we include it or not.
okay. And what Jack is gonna do, maybe build a small team to do that, to do the initial investigation.
Yeah, it should be small and lightweight.
Exactly. The other thing, Bijan, you mentioned is try to recruit people to help. So I
Yeah.
already sent an email with a couple of professors, and I already got those 3 guys making presentations. So you got 5 from me. You may get more from others. But in OCP, how you can recruit people or how you can get them to do work, I really don't know.
Well, I mean, we just make people aware of what we're doing, right? And so I can help spread the word and get everyone's attention on that. Hey, we're addressing this problem. Please join if you're interested. But yeah, so OCP is very voluntary, right? So people that want to participate in things, they step up and they do, or they don't.
Got it.
Yeah.
So, for example, Bijan, Monday we'll have this meeting with the IBM guys. So the guy know, I told him what we are doing, we are interested, but how we can get him to do work, maybe ask him or.
Yeah, I think we probably just need to say, hey, we want to do a survey as OCP, as this
Got
group,
it. Yeah.
right? We
Yeah.
want to do a survey. You want to
Yeah.
define, like, is this a worthwhile use of our time?
Okay, good. Thank you. Thank you, Bijan.
Well, Hesher and myself, and I think Brian were down at VeloxCon this week, which is more database stuff than AI. But one of the things that popped up is the guys did want metrics from the hardware as to what was going on, which I think maybe affects us as well.
Well, I would say that's a general software problem, but yeah,
Yeah,
I
it's just
guess.
so if you're trying to do something like AstroSim and you want whatever it does, you know, and you're trying to digitally twin the behavior you're seeing in the compute farm into something, you know, higher level models, you do need metrics from, you know, the hardware to say, you know, this is what's going on, what we're doing, and then you can sort of try and align the models with what's happening
Well,
to
of course.
reuse.
Yeah, I mean, how do you want to deal with latency? You need a metric,
Yeah,
right? So, yeah.
yeah, and they were complaining that if they did try and do it themselves, then, you know, it was like it affected, you know, if you stuck a probe in somewhere, then it slows things down. It's kind of their problem. And weren't getting good numbers.
Hey, Jack, do you have any update on AI Fabric side? I know Jay made a presentation. I don't know if any follow-up work on that.
So as I said, I have to reach out to Prakash. He was doing some piece. I've been doing some stuff in a Google Doc, and I'm going to move into work in progress. In terms of the document, and then I mentioned to Min Lan that we'll start scraping her some of the data she has that she's been building characteristics. So I've been working on the data services side, and Jay's been working on the scale up. So I'm going to ping him, and I have some front matter stuff. So we'll move it to the work in progress directory in terms of that. But that's the first thing we're looking to fit into the AstroSim part. So we're going to go through some pain in terms of kind of getting things going, but we'll go from there.
But back on the latency, you guys know how these things work. Things are distances and inherent latency of the response time of the device. But we normally try to hide latency. We try very hard in hardware, but then for general purpose software. But a lot of software algorithms that I'm hearing about with AI ML and the work that you guys are doing are willing to do pipelining and parallelism in software. They're willing to change their software and therefore hide latencies more effectively. So at some point, it would be nice to know to what level poor hardware guys need to reduce latency versus smart software guys can hide the impact of latency by moving data ahead of use.
That's a complicated question because I was just talking to some people yesterday who are very adamant of having a synchronous interfaces as a means to deal with latency as opposed to doing more async things that might give you better bandwidth but less reliable latency constraints. So I think to me it's a very loaded question and I didn't want to bring it up.
I mean, it's back into the networking space. I mean, I think you need to get metrics and requirements on any
But I'm
link
my
that you
point,
have.
Kevin, is that it affects some people looking at latency. It affects what their actual programming model is, and that's kind of the high
Well,
level.
I mean, say
That's what I'm saying
you know,
specifically to CMOC talking about the software side. It does this latency thing does get very complicated.
Yeah.
So,
but I mean, one of the things about going for spiking neural networks and neuromorphic stuff is that if you can break things down into the largest number of small compute components and the networking, then you can decide where the latency matters.
Yeah,
And
yeah.
where latency doesn't matter, you can say, well, I can send this to another processor to get done. If latency is a problem, I'll say I'm going to do that in the same processor and not bother funneling it somewhere.
I think you captured that very well, Kev. Thanks.
So Wei-Feng, I'll send you an update on the AI Fabric piece. I'll start working on the neuromorphic project proposal, workstream proposal.
Okay.
And then I'll post things to the work in progress and start getting things going there as well. And I'll send a note out to the group when everything gets kind of pushed up and going. And then, as I said, we're scheduling some time with Tushar to start going through the AstroSim side. But, you know, I'll share the tutorial and all the slides and all the pieces so you get to see, because he's done the tutorial updates. And as I said, he has students using it at a number of AI spaces. And so, you know, we'll see what we can do to leverage, but I think it's going to take a village. And what we want to do is see what we can do from the open source community to really kind of help move things forward.
Okay, is there a shared doc or shared folder for AI Fabric? Because I was looking at the OCP shared drive. I didn't see any
So Jay's been doing stuff privately so we haven't consolidated and move it up. So I'll create a work in progress directory and then I'll bug Jay to just grab his piece and consolidate what we have. And then I'll reach out to Prakash. He was doing some other pieces. And so we'll go from there.
Okay, yeah. So this way people make contributions while along he's working on
Yeah.
that.
Yeah. So because I've been asked, to your point, Weifeng, I was just asked a couple days ago, you know, people would like to start contributing. And so this would give everybody a chance to start contributing.
That's right.
And to CMX's point about now we can discuss terminology and things like that. So
yeah, especially people who has very active discussion on exactly what is a scale up, what is a scale up, right? Where's the boundary, right? Those things. Yeah, I know. The Josh made some. There was like blogs on that, so maybe we can also put certain points from there.
yeah, and Victor, to your point, you know, we are looking at a few workloads in terms of that, so we'll have that in there as well. Okay. So we're 1 minute past the hour. I appreciate very lively dialogue today. Anything else before we break?
I had a quick question for CMAC about his comment. It is good to articulate how different the hardware elements are for neuromorphic computing software algorithms. Maybe if we can elaborate on this.
I think we mostly covered it today. The concept of keeping your fences high to have good neighbors, having identifiable interfaces so people can work independently, identifying what hardware and software elements we already have that are standard, and interconnect them the way we like it for new capabilities as polymorphic or neuromorphic, and then identifying what gap is there so that we can define black boxes. All interfaces to the black box is no. Now get people to work on the black box itself, independent of the rest of the system.
Okay, good.
I stuck a couple of links for neural network definition in the chat. Netmonics.
And happy Easter, guys.
Happy Easter. Talk to you guys
Thank
later.
you.
Easter.
Thank you, guys. Talk to you next time.
Thank you very much.
Thanks. Bye.
Bye bye.